All right, so now we're going to continue our discussion of significant figures, but now with a focus on combining numbers with sig figs, right? So now we're going to perform an operation where we multiply, divide, something like that, in order to get a new number. And how do we carry our sig figs? Okay, so for example, well, step back. Basically, this whole process, you're going to have two steps. One is just treat it as a math problem, just like you normally would, punch it into your calculator, get an answer. Then the next thing you're going to have to do is go back and apply our rules for carrying sig figs to get the number of significant figures in your final answer. Okay. We're going to learn two different sets of rules. One rule for multiplication and division, and another rule for addition and subtraction. Okay, so if you're multiplying or dividing, you use one set of rules for carrying sig figs. If you're adding or subtracting, you use another set of rules for carrying sig figs. You don't want to get those two mixed up, okay, because they're very different sets of rules. Multiplication and division is actually the easier of the two, so let's start with that. So here's what the deal is going to be. You're going to be given a problem like this. 1.4 times 8.011 equals, you're just going to punch that into your calculator, and this is the answer that you're going to get, right? The problem is that I can't have an answer that's like more precise than the measurements that I was using to get that answer. Okay, so that's why we have to worry about carrying sig figs. For multiplication and division, you're going to count the significant figures of your input. All right, so in this case, 1.4, how many sig figs are in that number? I have 2 sig figs. In 8.011, how many significant figures do I have? This would be 4 sig figs. Your answer is going to have whichever number is fewer. So my answer can only have 2 sig figs, right? Because 2 is fewer than 4. So that means I'm going to round my final answer to 2 significant figures. So the last sort of answer that you're going to report is not 11.2154, but just 11. Okay, this number is too precise. We weren't that precise in our measurements, right? So when we're rounding to the correct sig fig, we're doing so to more accurately represent how confident we are in that number, how precise that number is. In this case, we're only confident about that ones place. Okay, so let's just do a bunch of examples. We're gonna, again, step one is just punch it into your calculator. Pretend like this isn't a science class, this is a math class. You're going to get whatever answer comes out the other end. Now you're going to go back and apply our rules for sig figs. Okay, so again, count the number of sig figs in each of your inputs. I got 2. I might use just a different color to represent sig figs. I have 2 in this number and 2 in this number, so that makes it easy. I know that my answer should have 2 sig figs, so I will round to 2 sig figs, giving me a final answer, in this case of 15. Okay, going to the next example here. Again, step one, just punch it into your calculator. See what comes out the other side. All right, now you're going to go back and make sure to apply your rules for sig figs. 12,000, how many sig figs are there? Remember, this will count, but I don't count those trailing zeros because there's not a decimal in that number. So this would only have 2 sig figs. Whereas this number, 1, 2, 3, 4 sig figs. So I'm going to round to this decimal, or to this place here. So my answer is 28,000. Now, I just want to sort of nip this in the bud because I know some students have this question. Well, why do I have to write these zeros? Can't I just write 28? Well, no, because 28 and 28,000 are different numbers, right? We have to make sure that we're using the same number. We're just sort of rounding to the last digit that we're confident in. 28 is not 28,000. 28,000 and 27,852 are very similar numbers. They just indicate a different level of precision. And if this is the only place, or rather the last place that I'm confident with, that's what I'm going to round to. All right, so 3.28 times 1.22 or 1.200. Again, punch that into my calculator. Then I got to apply the rules for sig figs. This has 3, this has 4. So 3 is the lower number. I'm going to round here, and that will round up to 3.94. Again, punch it into your calculator first. Then you can go back and apply your rules for sig figs. This has 2 significant figures because I don't get to count those trailing zeros because there's no decimal. This has 3. 2 is the lower of those 2 numbers, so I'm going to round to this second digit that's displayed here. And then again, I'm going to have to include all those trailing zeros because I can't change the number that I'm talking about. But importantly, this number also only has 1, 2 significant figures. Okay. Again, plug it into your calculator, punch it in, just see what comes out the other side. Now you're going to go back and apply your rules for sig figs. This has 1, 2, 3, 4 sig figs. I'm not going to count that trailing zero. And this has 3. So I'm going to round to this position here. And again, it rounds up, and I'm going to include those trailing zeros so that I don't change the number. All right, and now this last one is interesting. Kind of shows you the other side of things. The bottom line is your calculator doesn't know anything about sig figs. So if you punch in 10.00 times 10.00, what comes out the other side is 100, right? Again, the second step will be to go back and apply our rule for sig fig. This has 4, this has 4. So we're going to need to make sure our answer has 4 sig figs. So I'm going to write in that 0.0 so that in my final answer, I have 1, 2, 3, 4 sig figs. Okay, so you might have to add trailing zeros on there in order to get to the correct number of sig figs. Addition and subtraction is a little bit more of a pain in the butt. What you do is, first step is to line the numbers up at the decimal place, right? So I'm going to line my 2 inputs up at the decimal place. I can punch it into my calculator and get my answer out. Then I'm going to go and I'm going to mark the last sig fig in each of my inputs. In this case, it's here. In this case, it's there. Whichever position is further to the left is where the sig fig is going to be in your answer. Okay, so this position here, this number has the sig fig further to the left. So that means my answer is going to have its sig fig in that same place. So I would round what I got when I punched it into my calculator, the 102.731. I'm going to round that to that 3, making it just 102.73. Okay. These are not the same rules as we use for multiplication and division. Okay. You don't count sig figs when you're doing addition or subtraction. You line it up at the decimal, mark the last sig fig in each number. Whichever place falls further to the left, that's where your sig fig is going to be. This is the process that you need to do for for addition and subtraction. It's different than multiplication and division. The counting sig figs thing won't do it. Okay, so let's do a few examples here. So 5.4 and 5.7, right? What am I going to do? I'm going to take my 2 measurements and I'm going to line them up at the decimal. I'll punch that into my calculator to see what comes out the other side. But then I'm going to go through, now I'm going to apply my sig fig rules. I'm going to mark the last sig fig in each number. These fall in the same place, so that makes it easy. This should be the place where I round to. So in this case, my final answer would be 11.1. Notice again, I'm telling you that the rules for multiplication division don't apply, right? This had 2 sig figs, this had 2 sig figs, and my correct answer has 3 sig figs. It's a different set of rules than multiplication and division. It's about the place where those sig figs are relative to the decimal. Okay, so next problem here, 3.28 plus 1.2. I'm again going to take my numbers and line them up at the decimal. All right, so they're aligned. I'm going to take this and punch it into my calculator. This is what comes out the other side. Now I'm going to go and apply my sig fig rules. Again, mark the last sig fig in each number. That would be here, and that would be here. Whichever one is further to the left, in this case, it's in that 10th place, that's the sig fig in my final answer. So I will round to this position, making my final answer here 4.5. Okay. Keep going. So now notice that these numbers don't explicitly have the decimal written, but I know where it should be, right? So I'm going to line these up again at that decimal, even though it's invisible. I'm going to punch it into my calculator, and then I'm going to go back and mark the last sig fig in each number. In the 3900, it's that 9. There's not, right? There wasn't a decimal explicitly written in this number, so I don't get to count those trailing zeros. Whereas in 823, it's just that last 3. It's in the ones place. So whichever sig fig is further to the left, in this case, it's this one, that's the place that I'm going to round my answer to. So I'm going to have to round to this 7, giving me a final answer of 4,700. Okay. All right, so now we got 12,000 plus 2.321. Again, I'm going to line these up at the decimal. Okay, I can punch that into my calculator and see what comes out the other side. But now I got to go back and do my sig fig rules. This 12, the last sig fig is that 2. I don't get to count those trailing zeros. In 2.321, it's all the way in that 1000th place. But where's the sig fig in my answer going to be? Whichever one is further to the left. So in this case, it's that thousands place. So I'm going to round my answer to this. And so my final answer is 12,000. And notice sort of what these consequences for the rules of sig figs are in this case, right? I have this really inaccurate large measurement, 12,000. I'm only confident about that 1000th place. And then I have this really tiny, really accurate measurement that I'm adding. And at the end, the answer that I get is just 12,000 again, right? I wasn't very confident with that 12,000 to begin with. It could have been 11,000. It could have been 13,000. It's somewhere in there. So if I add on some very, very tiny, very precise number, it doesn't change that approximation, right? So this may look a little weird, but that's exactly the case. Okay. Now, what we were talking about exact numbers, right? Exact numbers, like you don't have rules of sig figs that apply with them. You can think about them as having like an infinite number of sig figs or something like that because they're perfect. So basically what that means is if, let's say that I have 3 pennies, each with a mass of 2.5 grams, how many, what's the mass of all 3 of them total? Well, with my 2.5, I have 2 sig figs, okay? Normally, I would look at this number 3 and say I only have 1 sig fig, but because we're counting, because it's a count, 3 pennies, you consider it as being exact, and so it doesn't influence how you assign sig figs to your final answer. Just like this number has 2 sig figs, your final answer should have 2 sig figs. We don't consider this at all because it's exact. Okay. Last was, let's talk about combining and carrying units, carrying versus combining. Okay. This is again, now we're talking about units within a particular math problem. With addition and subtraction, those units just carry. All right. Again, it's different sets of rules. For addition and subtraction, they carry. What does that mean? Well, basically, they have to match in an addition or subtraction problem. So 1.1 grams plus 1.2 grams plus 1.1 gram. My final answer is going to just be 2.3 grams. My units are going to carry. Grams plus grams equals grams. Grams minus grams equals grams. Same thing with any unit that we would be talking about. A meter plus a meter is going to give me an answer in meters. Equally as importantly, you cannot combine measurements using addition and subtraction if the units don't match. So here I'm having grams and I'm trying to add something in milliliters. Those units don't match, so this calculation isn't even possible. It doesn't make sense to try to add grams to milliliters or grams to meters or milliliters to Kelvin or something like that. It just doesn't make any sense to add mixed units. Okay, so units have to match and the answer will just be the same as those matching units. Multiplication and division are a little bit more complicated because any two measurements can be combined using multiplication and division. Doesn't matter what the units are. And at the end, your answer will have combined units. So if I take 1 centimeter times 1.0 centimeters times 2.0 centimeters, my answer is in centimeters squared, right? Another way to say centimeters squared is centimeters times centimeters. So just like I multiplied my 1 and my 2, I'm also multiplying the centimeter times the centimeter. Okay, and this could be with any units. So like 1.0 centimeters times 2.0 grams would give me 2 centimeters times grams. Okay, now sometimes some of those combined units don't make any sense. A centimeter times gram, that's not anything. But other combined units very much so do mean something. Okay, so centimeters squared, that's how we measure area, right? Centimeters is a length. If I wanted to know what the area of a square was, that would be in centimeters squared. So it's not always that the combined units actually have any sort of meaning to them, but nonetheless, we can use any units, combine them, and they sort of follow the same rules, almost as if they were variables in this problem. Okay, so another one would be if I'm going to take 2.0 grams and divide it by 1 milliliter, I sort of can look at the numerical part of that and just punch that into my calculator. That will give me 2. But then I have to look at the units part of that. And I'm taking grams and I'm dividing it by milliliters. So my answer at the end should be grams divided by milliliters. Again, I'm combining those units. All right, so let's throw this all together and do a few practice problems here. For A, I have 317.5 milliliters plus 0.675 milliliters. So 317.5 milliliters plus, again, I'm going to line everything up at the decimal point, 675 milliliters. So if I punch this into my calculator, I would get 318.175. I know my answer is going to be milliliters because it's addition and subtraction, so my units just carry. And then I'm going to go back and mark the last sig fig in each number. Where is the sig fig in my answer going to be? It's going to be in whichever one is further to the left. So in this case, I'm going to round to this ones place. So my final answer that I'm going to punch in would be 318.2 milliliters. Okay. Likewise, going to the next one, I have 47.80 liters. I'm going to subtract 2.075 liters. Okay, I could just punch this into my calculator. 45.725 is what I get out the other end. I know that it's liters because I'm adding or subtracting, so I just carry those units. Now I got to worry about sig figs. So I'm going to mark the last digit in each of my inputs, and whichever one lies furthest to the left, that's the column that my last sig fig will be in my answer. So in this case, I will round to 45.73, and again, liters. Okay. Oops. Oh, that's not gonna work. Okay. All right. So then for this one, I have 13.5 grams. I'm going to divide by 45.18 liters. Again, multiplication division, kind of nice because I don't have to worry about the stacking at the decimal, anything like that. I just go ahead and punch this into my calculator. This would give me 0.29888. Actually, let me move it up. This would give me 0.298804. The harder part here is that I'm going to have to combine these units. I have grams divided by liters, so that's exactly what I should have as my units. Grams divided by liters. Okay, what are the rules for carrying sig figs for multiplication and division? Is you count, right? So my top number has 3 sig figs, my bottom number has 4 sig figs. Whichever is fewer, in this case 3, that should be the last digit that I round to. So my final answer here would be 0.299 grams per liter. Okay. Cool. All right. We'll do the last two. I'm going to actually erase to make some room here. D. Again, because this is multiplication, it's actually, I don't have to worry about lining it up at the decimal. I can just punch this into my calculator and I get 7.34375. Paying attention to units though, I have centimeters times centimeters. So centimeters times centimeters, more conveniently written as centimeters squared. So that should be the units for this particular problem. And then if I'm going to pay attention to sig figs, I'm just going to count. The 6.25 has 3, the 1.175 has 4, so my final answer should have 3. So what I would report is 7.34 centimeters squared. Okay, now the last one, E, is probably the biggest pain in the butt we could have for addition subtraction problems. And that's when the numbers are given in scientific notation, because I'm actually going to have to take this out of scientific notation before I can actually add these up, because I could actually add them up in scientific notation. My calculator would do it just fine. But in terms of figuring out where that last sig fig is, that's what makes this kind of a pain. So I'd have to convert my 5.46 times 10 squared grams into standard notation. The way I'm going to do that is times 10 to the 2 to get it out of scientific notation, opposite of what we did before. I'm going to bounce it 1, 2, because there are 2 here. So 5.46 times 10 squared, this is the same thing as 546 grams. Then I'm going to add 4.991 times 10 to the 3. Since this is a 3, I'm going to bounce this decimal place 1, 2, 3. to get it out of scientific notation. So this is 4991 grams. Okay, so punching this into my calculator, I would get 5537. Again, my units are just going to carry because it's addition or subtraction. And then all that work for, they have the sig fig in the same place that one's place. So actually, this number as it's written is the correct answer. So final answer would be the same as what popped out of the calculator, 5,537 grams.